Good afternoon, everyone. So, in the last lecture, we have seen Lagrange's interpolation formula. Okay. So, what is a Lagrange's interpolation formula? We have seen. So, this is what a Lagrange's interpolation formula. And even in the last lecture, I have solved one example so that how can we can suppose we are provided with n plus one values. So, we will get the polynomial of degree. And so, this is way of finding the polynomial. Now, if suppose we want to find out a interpolation value, that means suppose here what is the question? Find the cubic polynomial from the given data. Why we are getting cubic polynomial? Because here we have four values. So for n plus one values, we get a polynomial of degree n. Okay. So what is an interpolation? Here now in the interpolation form, inverse interpolation. So you can see here in the interpolation, the process of finding value of x by the given values of y is called the inverse interpolation. So here we are provided with the. So what is provided to us here? We are provided with the values of x and y. But what is the condition? Initially, if suppose you are provided with values of x and y, and then suppose you want to find out a value in between somewhere. That is, if we want to find out a value of x is equal to 1.7. So you can find out this by using our Lagrange's interpolation formula. First, you have to find out a polynomial. Just now, just like in the last lecture, we have found the polynomial. After finding the polynomial, put x is equal to 1.7 and you will get the answer. That is for x equal to 1.7, what will be the corresponding value of y. But in the case of inverse interpolation, it is very similar to interpolation. But what is the condition? Instead of finding the value of y, here we are finding the value of x. So there is very simple change, that is wherever you are having x, just replace x by y by x in our Lagrange's interpolation formula. So whatever the formula new I am getting is, it will be this formula. So this is what a Lagrange's inverse Lagrange's interpolation formula. Okay. If you remember in the last lecture we have seen here all those we are having a values of x, and here we have f of x naught. Instead of f of x naught we have simply x naught. Here x1 up to f of xn. So these are the value, whatever wherever you are having x, just replace x by y and you will get the answer. So here if you see the example, this is the example we have to solve it by Lagrange's Lagrange's interpolation formula. If you see, we are provided with y1 is 4, y3 is 12, and y4 is 19. What is the values of these? That means value of y at x equal to 1 is 4, value of y at x equal to 3 is 12, value of y at x equal to 4 is 19, value of y uh, at some value of x is 7, but that some value we have to find out. That we can find out with the help of our Lagrange's interpolation. So wherever if you want to find out direct answer, that just directly put wherever you are having y, put the value which is unknown to us. That is, put the value of that y whose x is unknown. That means here you can put a value of y 7 and those corresponding value of y. Here this is y naught, y1 and y2. This is unknown value of x. So we have to find out corresponding to value of y equal to 7. We have to find out a value of x. So hence now if you get a, you can see here we are getting the answer is 2.4 something. I don't know exactly. You can calculate and you can get the answer is something. Let me check. So here we are getting the value of x is 1.8 something. Okay. In the next page you can see the answer is 1.86. Okay. So in this way you can use the Lagrange's interpolation formula, or in another way you can use inverse Lagrange's interpolation formula. So in the Lagrange's interpolation formula, wherever you are having the values of x and y are provided, so you have to first find out a polynomial, then put up a value of x. Then after putting value of x in our polynomial that we got by calculation, we can get the corresponding value of y. Suppose you get the polynomial in terms of x and you want to find out the value of x equal to 10. Then put x equal to 10, then you will get the corresponding value of y. In the very similar way, here we have to solve it for value of, instead of finding the value of y, we have to find out the value of x. So for given values of y, you can get the value of x. So you can calculate this and you can get the answer. Okay. So let me go for the next one. So now next point is a finite differences. I hope everyone are knowing upon what is a differences. Suppose you want to find out a very small difference between the values of x. Suppose in between x equal to 1 and x equal to 1.1. So what is the difference? 0.1. And we want to find out very smaller differences. So in this way, assume that we have set of n plus 1 values. Okay, that is for I equal to 0, 1 to up to n. So for those set of n plus 1 values and then corresponding values are given. So now we have to put it in the form of xi is equal to x naught plus ih. Suppose we are required to find out those values of f of x for some intermediate value of ix. So we want to obtain the derivative of f of x for some x in the range of this. Then the method for the solution this problem based on the concept of differences of function. First difference is called forward difference and another one we called as a backward difference. So first we will study the forward difference interpolation formula. Okay, or forward difference. So what is a forward difference? If you see here, we are provided with y naught, y1 up to yn. And if I want to find out difference between y1, y0, that is next value minus the previous value, y2 minus y1 and so on. So these type of differences we called as a first differences or first forward differences. And it is denoted by delta y, and delta y0 will be y1 minus y0, that is first forward differences. And what is the second one? Delta y1 is y2 minus y1, delta y2 is y3 minus y2 and so on. Okay. So here delta denotes the operation called a forward difference operator. So second difference formula we can also find out what will be delta square y naught, that will be delta y1 minus y naught. Okay. Next value minus the previous value, y1 minus y naught will be delta square y naught. And just put up a value of delta y naught y1 that we have calculated from the first differences, y2 minus y1. And what is the value of delta y naught is y1 minus y naught, and in this way we can get y2 minus 2 y1 plus y naught. And what will be the value of delta square y1? So next value is y2. Delta y2 minus delta y1 will be y3 minus y2 minus y2 minus y1. And then we can get the second forward differences. In this way we can calculate the third forward difference also. So what will be delta cube y naught will be delta square y1 minus delta square y naught. And just put up the values of delta square y1 and delta square y naught and you can get the answer. Okay. So if you observe here, so for first how many values we have? We have n plus 1 values. But in the first forward differences, that means for first one, how many values we will get? So here we have y0, y1 up to yn, that is n plus 1 values. So here how many values we will get? y1 minus y0, this is first, y2 minus y1, that is second, y3 minus y2, that is third, and so on, yn minus yn minus 1. Okay, so this will be the last one. So initially we have n plus 1 values. After finding the first difference, we will have only n values. After finding the second difference, how many values we will get? Delta square y naught, delta square y1 up to delta raised to n, delta raised to 2 yn minus 1. So we will get now n minus 1 values. As you are going to increase the order of our differences, that is first order, second order, third order. So you will get the differences will be that means values whatever we are getting values of y will be less. So in the second difference, now in the third difference, how many values we will get? Delta cube y naught, delta cube y1 and so on, delta cube yn minus 2. Right. So next in this way we can find out the answer. So in general we can see here delta raised to n yi minus delta raised to n minus 1 yi plus 1 minus delta raised to n minus 1 yi. Okay, yi plus 1 minus yi. Next value minus yi, that will give you the delta raised to n yi. Okay, so here this is a table. Here you can see the table. Values of x are given, values of y are given. These two column x and y are provided to us in our exam. So what we have to find out delta y, that is delta y naught, that is difference between these two values y1 minus y1 naught. Delta y1 will be difference between y2 minus difference between y2 y1. And in this way you can calculate all those values. What will be delta 5? Delta y5 will be difference between y6 and y5. So delta square y will be all those values. Difference between delta y1, delta y naught will be delta square y naught. So in this way you have to calculate. So if you see here, we have 7 values. This is x1, x2, x3, x4, x5, x6. These are 6 value and plus this x naught. So n plus 1 values. Okay, that is we have total 7 values. So here it is reduced to 6 and then reduced to 5, 4, 3, 2 and 1. And finally if you want to find out what will be delta raised to 4, sorry, delta raised to 7 by will be 0 because there is no any other values. So here you can get, as you increase the order of differences, it will the number of values we are getting will be less and less. So after some time it will be 0. That means if you want to find out, suppose we are provided with the 7 values, so seventh difference will be 0. Up to delta raised to 6 you will get the value delta raised to 6 by will be the only value. Okay, single value. So if you are having 7 values, so seventh difference will be 0. If you want to find out here next number, delta raised to 7 by will be 0. So in this very similar way, we have to find out the backward difference. So what will be the backward difference? The values will be same, but the notations will be different. Here you are using uh, forward delta, and this is a backward delta. Backward operator, for backward operator, we are using an inverted delta. So y1 minus y naught was our delta y naught, but here it is del y1. Okay, this is del y2, del y3, and so on. Okay. So here you cannot get the value of del y naught, okay, because it is a backward difference. So here if you see y1 minus y naught, y2 minus, the values are same. Here also we are having y1 minus y naught. You can see here y1 minus y naught, y2 minus y1 and so on. But here we have named it as delta y naught. But here we will name it as, so we can name this as del y1, del y2 and so on. So here also we have n plus 1 values will be reduced to n values for the first backward difference. Similarly, we have to find out delta square y2, that will be del y2 minus y1. What was in the forward? Forward में हम लोग क्या कैलकुलेट करते, y del square y3 होगा तो we will calculate del y4 minus del y3, but here we have to find out del y2 minus del y1. Okay, so this is a general formula for the backward differences operator. Okay, so this is also a table for the backward difference operator. So here we have set of 6 values. Okay, x1, x2, x3, x4 up to x5. These are 5 values plus x 0. So total 6 value. In the first one we will get a total 5 values. Okay, first backward difference. Second backward difference we will get only 4 values. For the third backward difference we will get the only 3 values and so on. So for if you are having 6 values, 6 divided 6 to backward difference will be 0. Okay, and this is what a general formula for the backward difference operator. Del raised to n yi is equal to del raised to n minus 1 yi minus del raised to n minus 1 yi minus 1. Here backward in the sense we are finding the difference with the help of this backward value. Okay, here we have yi, here we have yi minus 1. Forward means what? Here we have I plus 1 minus yi plus 1 minus y, then it is called a forward difference. If you see the general interpolation formula for our forward one, here it is y plus 1 minus y. But what is the formula for backward it is yi minus yi minus 1. Okay. So in this way, this is a formula for forward and backward differences. Okay. So let us go for the next one is a central difference operator. So central difference operator is denoted by delta. This is a notation for this, and delta y half is denoted by y1 minus y0. Again those values are same but the notations are different. This is called a central difference operator. Y delta y half will be y1 minus y0. So how it is going to work? It will be just like here it is half. Half plus 1, half plus half will be 1. Half minus half will be 0. Here also 3 by 2 minus 1 by 2 will be, sorry, 3 by 2 plus 1 by 2 will be 2, and 3 by 2 minus 1 by 2 will be 1. I am talking about the suffix delta y 3 by 2 plus 1 by 2. 3 by 2 plus 1 by 2 means 1.5 plus 0.5, that will be y2. So suffix of y will be 2. So 3 by 2 minus 1 by 2 will be 1.5 minus zero point 0.5 will be 1, that is suffix will be 1. Okay. So here this is a table for our delta value. Okay, it is, you can see here I have written. So all the values are similar, but here you can see y1 minus y0 will be forward delta y0, and this is backward delta y1. Here it is y0, here it is y1, as it is a backward. So we are finding the value with the help of a back values. Y1 minus y0. Del y half will be again y1 minus y0, because half plus half will be 1, half minus half will be 0 in the suffix. So this is what a now symbolic relation. Okay. So del forward operator del yr will be yr plus 1 minus yr. So here del backward for backward del yr minus yr is yr minus yr minus 1. Delta yr will be yr plus half minus yr minus half. So what is an averaging operator? Mu can be defined as, now this is new one. Mu is a averaging operator. In this lecture, we are going to just study the operator. First, we have studied the forward one, that is yr plus 1 minus yr. That means we have to calculate these values with the help of a next number. Yr plus 1 minus yr will be your forward operator. Now here forward difference, first forward difference, and this will be backward difference, that is yr minus will be the backward difference, and this is what a central difference, yr plus half minus yr minus half. Okay. So next we are going to see is the averaging operator. Now how we are going to define the averaging operator? Mu is, as the name itself suggests, that what is a averaging operator. Average means what? We are going to calculate the average value. So yr plus half plus yr minus half divided by 2. The two values we have taken, so we have to divide it by 2. Okay, now we will define the next operator is a shift operator. That means it is going to shift your yr value to next value, that is yr plus 1. Yr will be yr plus 1. That is, it is going to shift your value to the next one. Okay. It is going to shift y1 to y2. That is, if you apply e to y1, then you will get a e2. So what will be e square? It will be, if you apply e square to y0, it will give you y2. So here also you can see e square yr will be yr plus 2. So what will be e raised to n yr will be yr plus n. What is the relation between delta and e? Delta yr is yr plus 1 minus yr. So what is the value of yr plus 1? You can see here it is e yr. So if you take yr common, it is e minus 1. Okay. So in this way you can find out the relations. So this is what a relation between backward operator and ini. What is a backward operator? So here you can see it is yr minus 1. So instead of having e, here whatever minus 1, that we have to take to the power of e, that is e minus 1. So what I get the relation, backward operator is 1 minus e raised to minus 1. Okay. So next is what is the relation between delta, that is a central difference operator, and E. Third one, that is wire plus half minus wire minus half. So instead of whatever we are having plus, that you have to take to the power of E. What is E? E is a shift operator. E raised to half wire minus E raised to minus half wire. So you can get the relation. So what is the relation now in the fourth one? We have averaging operator. That is wire plus half plus wire minus half divided by 2. So whatever plus we are having quantity, that you have to take to the power e raised to half wire plus e raised to minus half wire. And then you can have wire get cancelled. So mu averaging operator 1 by 2 e raised to half plus e raised to minus half. So here you can get the values, and these are simply the relation that may be asked for 2 or 3 marks. You have to study all those relations I have given here. So you have to study all those values of relation. I will ask also for some questions based on this. Okay, so what I have seen here, let me go for the first relation that we will see. Okay, let us find out the relation between delta, that is forward operator, shift operator, and central operator. So for that we will start with the central operator, delta wire, that is wire plus half minus wire minus half. So now just in whatever we are having a wire plus quantity, that you have to put to the power of e, that is e raised to half wire minus e raised to minus half wire. Okay. Now, if you take e raised to half common, so what will be the value of this e raised to half? So this e raised to half minus half already we have. Again, you have to divide by e raised to half. So that will be half plus half is minus 1. So here we can get e raised to minus 1. So what is the value of 1 minus e raised to minus 1? Just now we have seen this is backward operator. So in the very similar way, let us find out the relation between averaging operator, central difference operator, backward difference operator, and forward difference operator. Okay. So just now we have written this is a relation mu is equal to 1 by 2 e raised to half plus e raised to minus half. Now let us take e raised to half common or something, we can calculate it is, what is delta? E raised to half minus e raised to minus half. So just we have to multiply mu into delta. So after multiplying mu into delta, you can get the values. Okay. So here what will be the addition of this forward and backward? It will be e minus e raised to minus half. So putting this in your equation 1, you can get mu delta, that is the average operator into central operator is equal to 1 by 2 forward operator plus backward operator. So here also you can get the relation between forward operator, shift operator, and the backward operator. E into, that is shift operator into backward operator will be E as it is. Value of a backward operator we have is, what is the value? 1 minus e raised to minus half. Just multiply e inside, what I get? E into 1, that is 1. Minus e into e raised to minus half. Plus half minus half will get cancelled. E raised to 0 will be 1. That is, we get e minus 1. What is the value of e minus 1? That is our forward operator. All those values, all those formulas you must by heart, so that you can solve all those in the exam. How many formulas you have to by heart? Forward operator, backward operator, central difference, averaging operator, and the shift operator. Okay. So these you have to by heart. Now let us see what will be the difference between forward and backward. If you calculate this, you can see you will get both are equal. You have to prove it. Next, these are the examples you can see, and you can solve the example. So next is our relation between d and e. Now initially I have told you that we have to find out the derivative also. Okay. So this we will take in the relation between d and e. What is e? E is a shift operator. Now what is d? D is a derivative. Okay. Relation between d and e we have to find out. Again we have to use our Taylor series formula. Taylor series formula for y is yx plus h is equal to yx plus h y dash of x plus h square by 2 factorial y double dash of x and so on. Now, wherever you are having this can be written in the symbolic form like this. Okay. Instead of having y dash, we can write it with the operator d. D is notation for our derivative. Okay. Ey x, that is it will give you the shifting. Okay, here yx plus h, that is e raised to h. Okay, so here you can get the values. Now method of separation of a symbol is the next point. So for this, number of identity can be defined by using shift and backward of forward, backward, central, and averaging operator and shift operator. Okay, so using the method of separation, we have to solve this example. Okay, what is the example? Delta raised to n, that is forward difference operator raised to n ux minus 1. This is we have to prove. So let us go with the RHS. Ux, all these values are given. So what we have to do, whatever you are having x minus 1, that where there you have to use e raised to minus 1. X minus 2, so ux minus 2, so you have to use e raised to minus 2, and then you can calculate 1 minus n minus, so this will be the formula for 1 minus e raised to minus 1 raised to n. And what is the value of e minus 1? So 1 minus e raised to minus half will be 1 upon e. Just multiply e, take the LCM, you can get e minus 1 divided by e raised to n. So here what is the value of e minus 1 is forward difference operator raised to n divided by e raised to n. So it will be this 1 upon e raised to n will be and the e raised to minus n, and then so you can get delta raised to n ux minus n. Okay, delta raised to n you have to take outside. So what is e raised to minus n? Ux will be ux minus n. Okay, so in this way you can solve the example. In the next lecture we will see Newton's formula for interpolation. Just now we have seen Lagrange's interpolation formula. In the very similar way, with the help of a forward operator and backward operator, you can find out the interpolation. That is Newton's forward difference interpolation formula, Newton's backward difference interpolation formula, and Newton's general interpolation formula. Okay, thank you.